Okay, well, I made this video once, and then the recording got deleted, so here we go again. Today we're talking about trapezoids. Trapezoids are quadrilaterals that have one pair of parallel sides. Those parallel sides we call bases, and we refer to the height of a trapezoid. The height is going to be the perpendicular distance betwixt the bases. Notice that I have underlined perpendicular. Right? The height has to be this right angle over here. It is not the length of this side. With the pyramids, we referred to that, pyramids and cones, as the slant height. That's not really the same thing in a two-dimensional shape, but same idea. The height has to be perpendicular. Just about any time we're talking about height, using the word height, it's going to be a perpendicular distance. Okay. So, notice if we took the trapezoid and made another one, doubled it, and flipped it upside down and pieced them together like this, we could get the overall shape of a parallelogram. The area of a parallelogram is base times height, right? Base times height. The base of this guy is just the bases of the trapezoid added together. We have the bottom base and the top base because this one's upside down. So that's just going to be base 1 plus base 2 times the height. Well, the height of the parallelogram is the same as the height of the trapezoid, and it's that guy, base times height. So area of a trapezoid is 1/2 the height times the sum of the bases. Notice it's 1/2 because up here, if I do base 1 times base 2, base 1 plus base 2 times the height, I get the area of this whole thing. I don't want the area of both trapezoids. We just want one of them. So I have to cut it in half to only go back to the original. Okay. So I'm going to give you a second with this. If you want to put anything else in your notes, I'll move this so you can see everything. Definitely make sure the formula's on that note, the formula sheet. Make sure you have that formula sheet out. We'll be adding to it a couple times today. This would be a great thing to put on there. So go ahead and pause the video for a second and copy down whatever you need. I'm going to keep moving. So, on your own, I want you to find the area of the glass used to make the windshield of this van. It's a trapezoid. We have two different parallel bases, the top and bottom, and a perpendicular height. So just give it a shot. Plug and chug. Go. Pause the video if you need to. Okay, here we go. Area is 1/2 the height times the sum of the bases, 72 plus 85. So I'm doing 0.5 times 38 times, in parentheses, 72 plus 85. I'm punching this whole thing into my calculator all at once. No reason not to. You don't have to put it in all at once, but you certainly should. Looking for units, these are in inches, which means this has to be inches squared. Piece of cake. Amelia designed the pennant shown for her team. Find the area of the shaded portion of the team's pennant. So the whole pennant is this kind of triangular type shape. Now we know it's a trapezoid. This 10 inches is a base. This is the height. You might be tempted to call this the other base, but notice they're not parallel sides. This is the other base. So we're going to need to find some stuff. First thing we should probably do is cut this into two pieces. This is a 10 still. We have a little rectangle down here, and we have this big triangle. Using this right triangle, we can figure out what this guy is. Once we know what that is, we could also figure out what this is, and we can go from there, because these two are going to be the same, right? This is the piece that I need in order to do the trapezoid. So I'm going to think Pythagorean theorem. A squared plus b squared equals c squared. So 8.5 minus 4 squared is going to be equal to L squared. So 8.5 squared minus 4 squared, 16. I get 56.25. 56.25 is equal to L squared. Square root of that, we get plus or minus 7.5. I decided to take the square root, so I got to include both. Now I got to think about this. Could this possibly be a negative 7.5 inches? No. You can't measure anything in negative 7.5 inches. So L has to be 7.5, which means that X has to be 2.5, because remember, together they add up to 10. So now I can go back to the formula for the trapezoid. Here's base number 1. That's 10. Base number 2 we now know is 2.5, and I have my height. So area is 1/2 the height, 4, times the sum of the bases, 10 plus 2.5. So you can do this one in your head. These can cancel. This becomes a 2. So I really have 2 times 12.5, or 25 inches, looking for my units, squared. You can also just plug that whole thing into a calculator. Rhombi and kites. Okay, a rhombus is a parallelogram with all 4 sides congruent. So parallelogram, it's got opposite sides parallel, plus all 4 sides are congruent. You're definitely going to want that in your notes, maybe even on the formula sheet. The other definition, a kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. That's the one I want to talk about more. So exactly 2 pairs of consecutive congruent sides. So consecutive means the opposite of opposite. So it means that the sides are next to each other. Right? These oops, that's not what I wanted at all. These markings mean that these 2 things are congruent. The single dash means that those 2 things are congruent. Consecutive means they're touching, right? They're not across from each other. In a rhombus, all 4 are congruent, both consecutive and opposite. In a kite, only the consecutive sides are congruent. The areas of these shapes are related to the lengths of their diagonals rather than the lengths of their sides. Okay, and the formulas are the same, because a rhombus is a kite where both pairs of consecutive congruent sides happen to be the same. It's just going to be 1/2 the product of the diagonals. We're just going to multiply the 2 together and cut it in half, which is kind of crazy because it suggests that if I were to turn this rhombus into a rectangle, so that the length and width of the rectangle are the diagonals, there is just as much white stuff here as there is blue stuff. The unshaded area, this stuff, if I add all of this up, I get another rhombus's worth. So all 4 of those triangles could make another rhombus, which is kind of cool. Okay. Again, I'll let you pause here and put down anything that you want to in the notes. I'll move that. I'm going to keep moving though, so pause if you need to. All right. I want you to try these 2 on your own. Go ahead and pause for 2 minutes and try both of these. I want to point out real quick that this length right here is just half of the diagonal. It's not both diagonals. Okay, so don't let that throw you off. Go ahead and pause and go. Okay, here we go. Area is 1/2 the product of the diagonals. Diagonal 1 times diagonal 2. So this is 1/2 of 8 times 15. I like to combine those right away, make that 4 times 15, and I know that that is 60 meters squared. Down here, this double hash means that it's congruent with this piece. So really that diagonal is 20. This single hash means it's congruent to that piece. So this is another 12, meaning that diagonal number 2 is 24. So I really have 10 times 24, I combine those, which is 240 feet squared. Piece of cake. One diagonal of a rhombus is twice as long as the other diagonal. If the area of the rhombus is 169 square millimeters, what are the lengths of the diagonals? So I know that 169 has to be equal to diagonal 1 times diagonal 2 times 1/2. The problem is I have 2 variables, and I can't solve an equation with 2 variables. So I'm going to need to write another equation so that I have a little system that I can use to solve. So I need another piece of information, and what it says is that one of the diagonals, so I'll call that diagonal 1, is twice as long. So diagonal 1 is 2 times diagonal 2. That's all we got to do. This equation, I can plug this right there, and then I will have an equation with only one variable. Okay, so I just replace this diagonal 1 with this 2 times diagonal 2. This is a 1/2. Now notice the 1/2 and the 2 cancel. So I have 169 equals d times d, which is d2 squared. So I just need the square root of both sides. Square root of 169 is plus or minus 13. But it has to be positive, right? Because I can't have a negative length of a diagonal. So d2 is 13. I don't know what d2 or d1 is, but remember this equation right here? It's double. So if d2 is 13, then d1 has to be 26. This is in square millimeters, so these are also in millimeters. And that's it. Final answer. Okay. Last thing, here's kind of a summary of all the different shapes we've talked about so far and their areas. Parallelograms, triangles, trapezoids, and then rhombi and kites. Areas are down below, things are labeled. You should have all of this in your notes and on your formula sheet, but go ahead and pause right here and finish anything up that you need to. Homework is day 2. Good luck.